Okay, so what we're going to do here is look at a few problems on 5.6. 5.6 is a really nice problem. It tells us to divide and check. So one thing I want to review really quickly is something like, let's just say we had a fraction like 1 over 2 plus 2 over 2. Well, we remember when the denominator is the same, we just write it one time and we just add our numerators. Alright? And then we'd work it out and we would get a solution like 3 over 2. So basically what we're doing here in essence is we're working backwards. Okay, we're starting off with something like 1 plus 2 over 2, and they just want us to break that up as in two separate fractions. Okay, so that's exactly what we're going to do here. We have this fraction on our numerator. We have 30x8 minus 30x to the 6th plus 18x all over 6x. Well, just like this example, what we could do is break it up into three different fractions, keeping the denominator the same. You have 30x to the 8th over 6x minus, because that's a minus, 30x to the 6th over 6x plus, this time because that's a plus 18x over 6x. Now we're just looking at it like we were before. We're going to be following the quotient rule here. We'll be subtracting there. That's like a 1. Well, 30 divided by 6 is 5. Our base stays the same. 8 minus 1 is 7. Minus, because this is a minus sign, 30 divided by 6 is 5 again. That's 6 to the 1. This is x to the 1. Once again, bases are the same. We just subtract the exponents. 6 minus 1 gives us 5. And now plus, because that's a plus, 8 divided by 6, or 18 divided by 6 is 3. We see our x's will cancel. And there we go. That's our solution for the first problem. We're going to look at a few more. It's going to be all the exact same. So once again, we can break it up as three separate fractions. Our denominator will be the same. You got 15a to the 5th over 5a minus, because that's a minus, minus 5a to the 4th over 5a, then plus, because this is a plus, 10 over 5a. Once again, remember, the denominator stays the same. And now we just work this out. 15 divided by 5 is 3. My bases are the same, so I'm just going to subtract. We know like that's a 1. 5 minus 1 gives us 8 to the 4th. Minus, these 5's cancel. You just get 1, so we don't have to show it, or you can if you'd like to. And this is a 1 there. 4 minus 1 is 3. Minus 8 to the 3rd. Plus, well, 10 divided by 5 gives us a 2. But the thing is, there's no a on top. So this a is going to stay on the bottom. A little different from this last one, okay, from the previous one. Previous one, we had just all whole numbers, no fractions. It's okay to get a fraction, as you can tell here. 10 divided by 5 is 2. But we still have an a. Since there's no a in the bottom, our a will still stay on the bottom on the denominator. So you'll be seeing some tricks like that as well with these problems. Let's look at the same next problem. What's going to be the same? The denominator. How many fractions? 1, 2, 3 fractions. 48a to the 4 over 6a to the 4th minus 42a to the 8th over 6a to the 4th plus 24a to the 10th over 6a to the 4th. Once again, we go ahead and reduce these. 48 divided by 6, does that give us 8? 8 to the 4th, 8 to the 4th, those cancel. Minus 42 divided by 6, does that give us a 7? And 8 minus 4 is 4, so 8 to the 4th. And then we get a plus. 24 divided by 6 is what? 4. And this time we get 10 minus 4 gives us 6. So you see that's our solution for this one. So remember, every time what is not changing is the denominator. As long as you're dividing some kind of binomial or trinomial by a monomial, the denominator will stay the same, which will be very different from the next section. Same thing here. Denominator will be negative 2 9 to the 6, so we'll have 1, 2, 3 fractions. 2n to the 8th over negative 2n to the 6th plus 16n to the 7th over negative 2n to the 6th minus 12n to the 2nd over negative 2n to the 6th. So 2 divided by negative 2, we'll just get negative 1. 8 minus 6 is n to the 2nd. This positive 16 divided by negative 2 is going to make it a negative 8. 7 minus 6 is just n. And this negative 12 divided by negative 2 is going to be a positive. So we know it's going to be a positive 6. And 2 minus 6 is n to the negative 4th. But we have a negative exponent, so we can make that a positive exponent. We already learned that. So I'm going to just ignore this negative 1 now. Just make it negative n squared minus 8n plus 6 over n to the 4th. Remember, anytime you have a negative exponent, you make it positive by putting it in the opposite. That's like it's over 1 in the numerator, so we're going to put it in the denominator there. So this last one, it says the area of a rectangle is given by this polynomial. What polynomial expresses the length? So let's recall the area of a rectangle is length times width. The area is this. They're telling us that the area is that. So we're going to just replace a with that. 42x to the 3rd plus 24x squared minus 18x plus 6 equals, well, the width is 6 times the length. Well, how do we get L by itself? We divide by 6. So now you notice, just like the previous problems we were doing, we're just going to separate. We're going to have 1, 2, 3, 4 fractions, and the denominator will be 6. Over 6 plus 24x squared over 6 minus 18x over 6 plus 6 over 6 gives us L. We just simplify this. 42 divided by 6, 7x to the 3rd, 24 divided by 6, 4x squared, 18 divided by 6, negative 3x, 6 divided by 6, plus 1. That will give us our solution there. So there you have it. That is how you do 5.6.